One, two, one, two, one, two. One, two, one, two, one, two. Right, we're on. VK3 Echo Kilo Hotel in the last broadcast for the year. This is VK3 EKH broadcasting on the prime frequency of 3541 kilohertz, and just going to bring that level down on the vmix so YouTube isn't distorting. 1 2 3 1 2 3. It should be a bit better for YouTube. 1 2 3 4. Okay. Good evening, everyone, and we're broadcasting on the prime frequency 3541 kilohertz, and also by the Melbourne television repeater, VK3RTV on digital channel 1, and also on the YouTube stream. Just type in VK3CSJ on the YouTube search engine and look for the live action symbol. And we're also, well, that's it. And we have an email address if anybody wishes to send signal reports, vk3ekh@gmail.com, vk3ekh@gmail.com. And we also have Discord, a Discord chat window operating as well. So if you've got, if you just go to Discord, DISCORD, Discord on the internet, and log in as such, and type in astronomy chat room. I think that'll get you there. Oh dear. Anyway, pleasant good evening to everyone on this 22nd of December. And as we rapidly come up to Christmas, I wish everybody a great Christmas. It looks like the weather's going to be pretty ordinary on Monday. So it's going to be an indoors Christmas for a lot of people. But anyway, look, have a happy Christmas and a merry one if you so desire, and also all the best for 2024. This new year coming up, so I'll get that out of the way first. All right, this will be the last broadcast for the year. I go off for 4 weeks, as you know, as I've been mentioning before. I'll take a sabbatical, a 4-week sabbatical, and come back on the 19th of January, and do it all over again. Hopefully, I'm hoping that by that time I'll have the Radio Shack here relocated downstairs, and hopefully in a slightly better arrangement than it is here. Although one would think that after 11 years in this location and being up here in the upstairs environment, I'd have things sort of okay, but not really. It's just never been to my liking at all. That's why it's a constant mess. Anyway, there it is. So, okay, let's just go through the usual readout here. For the people that are tuning in for the first time, the Astronomical Society of Victoria was founded in 1922 and has well over 1,600 members scattered about Victoria and Australia and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy and to disseminate the knowledge of the science and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, where the latter will be held on a Saturday night. These meetings start right on 8 p.m. at the Mullior Hall, National Herbarium, at Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located adjacent to the Shrine of Remembrance. Parking is available Burwood Avenue, Dallas Brooks Drive, and the surrounding streets. Admission is free, and visitors are most welcome. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at the Melbourne Observatory, receipt of the ASV's magazine Crux, containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and a photoheliograph are also housed at the observatory and are accessible as well. The Society also has a number of 200mm reflectors available for short period loan in the ASV's telephone loan scheme. so members can try before they buy type idea. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger two with appropriate training, and they range from 300mm to 1000mm in aperture. Also located on the site is a fully steerable 8.5 metre, 30-foot steerable telescope, which members can access with involvement in the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same thing. Instrument making is only one of the number of common interest activities catered for within the society, actually. And I'll run through the various sections this time in alphabetical order. You've got astrophotography, club section, comet and meteor section, computing section, which has just renewed its directorship, and there's a new person now involved with the computing section. So that's a new section. It's not a new section. It's just been recently out of action, and only in this last few weeks has it come back on into action again. So if you're into computing, the computing section is bound to be up your alley. Cosmology and astrophysics, deep sky, the historical section, instrument making, juniors, lunar and planetary, new astronomers group, radio astronomy, solar astronomy, space exploration, and women in the ASV for the ladies. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It used to be 20 sections. There's some are missing here. Diurnals is one. Yeah, Diurnals used to be a Tuesday morning meeting. I haven't seen, nobody's replaced the director there, moved on. So okay, there's probably one or two sections that are missing there. But nevertheless, if any of those sections sound of any interest to you, you'll probably be more than welcome, I would say, to get in contact with the section director. And that information can be found under those section tabs. So if you go to the ASV website, under the sections tab where I've just read out all those sections, they're all individual pages, and usually you'll find contact details for the section director that runs those areas, and you can always email the director and ask if it's possible to sit in on a meeting, and from there, of course, discussions about perhaps being a member can also be done. What's involved? Contact details for various section directors are provided in the yearbook, but like I say, if you don't have the yearbook, because you can only have the yearbook if you're a member, all that information is available off the ASV website. Further information may be obtained by visiting the ASV website at www.asv.org.au. And notifications of events are given in the Crux Extra Bulletins, and the Crux Extra Bulletins are a email newsletter which is sent out almost randomly, but generally sent out every other week, just to keep members informed of what's going on, what's coming up in the next week or so. So it carries that sort of information. Please note that ASV will conform to all government health directives. ASV events may be required to be cancelled, moved or postponed. If you wish to write to the Secretary of to the ASV, address it to the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. That's the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. But generally, the internet, the webpage should be able to supply most of the information you'll be able to need to know about the ASV. I can hear myself coming through something in here, and I think it might be the speaker on the floor. Hang on a sec. All right, yes, it's one of these PC speakers that's prone to detect RF. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, coming to you from Narre South, VK3CSJ Studios. Okay, I've got just a short bunch of articles. If we can get through them quickly enough, we might be over and done with by 11 o'clock, but I know I always say that. A pleasant good evening to Steve, VK3SPX, Martin, VK7JAH, and Steve, VK3SPX again on the chat window. And no emails coming through at this stage. Not that I can see. Oh, there might be. Hang on a sec. Just realised that my page is not in the right spot. Let me just push my page down. I think that's right. No, that's it. Okay, we've got Andrew checking in. VK3KIS. G'day, Andrew. Armchair copy into Ringwood. And Stephen is also reporting great signal, a little weaker than usual. Okay. We'll turn the beam in your direction. Okay, first article off the rank here tonight. And they're all rather short, but one's a bit longer than the others. But anyway, we'll get through it. And I've got no glass of water with me here tonight, so just bear with me. Courtesy of astronomy.com, the Andromeda and Milky Way collision explained. The Andromeda and Milky Way collision explained. In about 4 billion years, our home galaxy will merge with the nearest large spiral in our local group, and here's what will happen. The Andromeda galaxy is approaching the Milky Way at nearly 250,000 miles per hour. It is the closest major galaxy to our Milky Way and is the most distant thing you can see with the naked eye at 2.5 million light years away. Absolute chaos will begin as the two galaxies approach each other, eventually becoming Milkomedia, they say here, but I think it's just a bit of a joke on words there. Milkomedia, the combination of Milky Way and Andromeda, of course. Everything will look like a massive pinball game, with huge amounts of rocks and dust and asteroids and planets and stars being thrown in all directions. Sounds like a real chaos thing, doesn't it? There's a little artist's impression here, so I'll just bring that up. If I suddenly drop off air, it's because my cat is gone behind the bench and she's doing something. But that's where all the mains outlets are in this shack. And if she pulls out a lead, that's it, I'm gone. All right, let's put up this artist. Oh, my God, Kiska! Okay, where's this artist impression? There it is. All right. And there's... Oh, my other camera is on the Flywire screen. Hang on a sec. Kiska, will you get out from behind the bench, please? Be a good puss. Oh, I don't know what she's up to. All right. So, getting back to the article. Until 2012, it was not known whether the collision was definitely going to happen or not. Researchers using Hubble to track the motions of stars in Andromeda and with unprecedented accuracy concluded that the galaxies would collide in about 4 billion years. Such collisions are relatively common, considering that galaxies have long lifespans. According to the simulations, the remnant will look like a giant elliptical galaxy, which is a blob-like galaxy without discernible spiral arms or an internal structure. So it sounds like it'll be radically different to what we know our own galaxy looks like at the moment. Andromeda Galaxy contains about 1 trillion stars, and the Milky Way contains about 3 billion. The stars involved are sufficiently far apart that it's highly improbable that any of them will actually collide. For example, the nearest part of the Sun is Proxima Centauri. Which is about 4.2 light years away. If the Sun were a ping pong ball, then Proxima Centauri would be a pea about 680 miles away. All those stars are more common near the centres of each galaxy. The average distance between stars is still 100 billion miles. That is like placing one ping pong ball every 2 miles. Thus, it is extremely unlikely that any two stars from the emerging galaxy would collide, but some stars might be ejected. So what happens to the black holes after the Andromeda and Milky Way collide? The Milky Way and Andromeda each contain central supermassive black hole. These black holes will eventually spiral into one another and converge near the centre of the newly formed galaxy over a period that may take millions of years. When the supermassive black holes come within 1 light year of another, they will begin to strongly emit gravitational waves that will radiate further orbital energy until they merge completely. Gas taken up by the combined black holes could create an active galactic nucleus. If this happens, it would release an inconceivable amount of energy. So what's the future of our solar system, you might ask? And there's another little illustration here. Okay. Oh, Keska, what are you up to? Okay, so this illustration on the screen at the moment shows a stage of the predicted merger between our Milky Way galaxy and the neighbouring Andromeda galaxy. In this image, representing Earth's night sky, is 3.75 billion years. So Andromeda fills the field of view and begins to distort the Milky Way with a tidal pull. Based on current calculations, scientists predict a 50% chance that in a merged galaxy, the solar system will be swept out 3 times farther from the galactic core than its current position. Our galaxy is organised into spiral arms, and the Sun is in a branch called the Orion Spur. If we were to be flung farther out, that means our solar system would land just at the fingertips of this arm. Scientists also predict sometime during the collision there is a 12% chance that the solar system could be entirely ejected from the newly formed galaxy. So for some reassurance, humanity would be long gone by then, of course. Such an event would eventually have no adverse effects on the solar system, and the chances of any sort of disturbance to the Sun or the planets themselves may be remote. That is excluding planetary engineering, of course. Wow, planetary engineering. By the time the two galaxies collide, the surface of the Earth will have already become far too hot for liquid water to exist due to the gradually increasing luminosity of the Sun, ending all terrestrial life as we know it. But our planet will be caught in the middle of this collision, and its view of the universe will never be the same. If we could, however, see the night sky still, whether from the hellish perspective of Earth or from afar reaches of the outer solar system, Andromeda would be growing larger in the sky, and eventually, about 4 billion years from now, it could possibly stretch from horizon to horizon like a serene rainbow of dew. Yes, it will be a very spectacular view. That is absolutely for sure. And it'll be nice to know that we'll be still around in some fashion, even though, as the article says, Earth itself will be in a pretty bad state of affairs due to the sun's changing state. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast, coming to you from the studios of VK3 CSJ, Narre Warren South. And this is the final broadcast for the year. I'll be taking 4 weeks off and coming back on the 19th of January. All right. All that preamble should have got me my next article ready, but I didn't. All right. Now, this one is courtesy of astronomy.com again. Why are open clusters and globular clusters found in different places is the question being asked by a fellow in New Jersey. And we have a picture here that I can bring up, part of this article. Okay. Just a second. All right, so what we have here is a failure to communicate. Someone once said, why are open star clusters in the disk of a spiral galaxy while globular clusters, or what globulars, are in the halo? So they're saying that why are open star clusters found more often in the spiral arms of the galaxy while globulars are in the halo? Is the same true for irregular and elliptical galaxies? And response to that is, in the first before I go on, the picture on the screen right now is real images. They're open star clusters like NGC 2547 left form and stay in galactic disks, while globular clusters like 47 Tucani or NGC 104 on the right side may be kicked out of such regions and into the halo shortly after forming. Is what that is. Those two images there. So the differences in location between open and globular star clusters result from the interplay between gravity and rotational motion. This rotational motion is called angular momentum and is a conserved quantity. It is what keeps planets orbiting stars instead of succumbing to gravity and spiraling inward. Angular momentum helps organize matter into disks. Disk-forming scenarios start with gravitationally bound matter with random motions. Over time, as this cloud of matter contracts and begins to orbit a common center of mass, collisions between particles cancel out their random motions and they converge, forming a spinning and flat disk. There's no and. It's forming a spinning flat disk, full stop. From this tug of war between gravity and angular momentum, the gas and dust in a spiral galaxy lie close to the plane of the galactic disk, in a region we call the thin disk. The abundance of such material, is why the young star forming open clusters are located preferentially in the thin disk. Once young stars leave their open cluster cradles, gravitational interaction with the multitude of other stars in the galaxy causes their motions to become more complex, eventually forming the thick disk of older stars enveloping the thin disk of younger stars. Globular clusters are also formed in gas-rich environments similar to galactic disks, but with higher gas pressure. We believe globular clusters are now mostly in the galactic halo because these old systems are kicked out of those high-pressure gas-rich regions relatively early, therefore undergoing less gravitational disruption ever since. This is likely also the reason why globular clusters are significantly more massive than open clusters. It's hard to define different components in elliptical or irregular galaxies. Ellipticals have stellar populations billions of years old, whereas globulars are much more common. With such ages, typical open clusters have dissolved into the smooth stellar component of their parent galaxy. So yes, there's just a little bit of description on open and closed clusters as such. In fact, globular clusters, like I was just showing on the screen there, the one on the right, are a pretty spectacular image to see through a telescope. There are a multitude of globular clusters in the sky above our heads, and if you know where to look, they're usually fairly obvious to the naked eye. Through a telescope, that is. So they are. I've seen like this particular cluster here, Tucani 47 Tucani, that literally can fill up the entire eyepiece of your viewing on a telescope. It's and it is quite bright to the eye too. Most interesting. All right. Next article. This is VK3EKH, and was there any images for this one? I think there was. Oh yeah. Let me just queue up that image, and there is a video associated with this too. All right, this is to do with NASA Apollo mission, Apollo 14, in fact. And this is another Ask Astro question to astronomy.com, courtesy. How far could a pro golfer hit a ball on the moon? Have you ever wondered that? Roy McIlroy. I think he's a well-known golfer. I'm not sure. Anyway, it starts off by saying Roy McIlroy could hit a lunar golf ball a staggering 4,582 yards. My goodness, yards. Or 2.6 miles. Americans. Anyway, some 50 years ago, Alan Shepard hit some golf balls on the moon during the Apollo 14 mission. Just how far could a tour pro hit a golf ball on the moon if they weren't encumbered by a spacesuit? Asks Jim from Vancouver, Washington. G'day, Jim, if you're listening. Alan Shepard shanked. It's one of those American terms. Alan Shepard shanked his first shot into a crater, but estimated that his second reached a distance of about 200 yards, or 183 metres. However, evidence from photos taken during the mission and remastered in 2021 suggests that Shepard managed to only hit his second golf ball some 40 yards, or 36.5 metres. So, to be fair, Shepard was restricted by more than just his bulky spacesuit. This makeshift golf club wasn't exactly regulation, just a 6-iron head attached to a collapsible tool designed to scoop lunar rocks. And there's an image here which I'll bring up right now. Okay. And where's me? There we are. Now, this is this high remastered image that they were talking about, because what you can see in that image are two circles with ball 1 and ball 2 on the moon surface. And image specialist Andy Saunders analysed archival stills taken by the astronauts and was able to measure the distance of Shepard's second golf shot. So an unencumbered golfer on the moon would certainly be able to do much better. According to PGA Tour stats, pros average 299.9 yards or 274.2 metres per drive during the just finished 222-223 season. If they could replicate the same ball striking technique on the moon, how much farther could they drive a ball? To calculate that, we have to dive deeper into the stats. For this past season, the average tour pro was imparting a ball speed of 278.18 kilometres per hour and launching the ball at an angle of about 10 degrees off the tee. Factoring in lunar gravity, roughly 1/6 that of Earth's, the laws of projectile motion tell us that an average tour's pro tee shot would carry about 1,044 yards or 1,317 metres. Now, you may have noticed that despite the moon having only 1/6 the gravitational pull of Earth, the distance we've calculated for an equivalent lunar tee shot is significantly less than 6 times the distance of the average tour drive, which would be roughly 1,646 metres. That's because on Earth, air helps a golf ball fly farther. A golf club imparts backspin to a ball, which allows the ball to generate aerodynamic lift and keeps it aloft. The lower launch angle of a driver is the most efficient way to maximise that lift while also minimising drag along the ball's trajectory. So while the moon's reduced gravity helps the ball travel further, perhaps counterintuitively, the lack of air on the moon reduces the distance again. Reduces distance gain is what it said, at least when assuming that our lunar golfer is using equipment and generating launch angles and ball speeds similar to those on Earth. In order to truly exploit the lack of air resistance on the moon, a golfer would need to launch a ball at the ideal ballistic angle of 45 degrees, while also maintaining ball speed. That's trickier than simply selecting a club with more loft. A more lofted club would slide under the ball and impart more backspin, converting less of the energy of the impact into the ball speed. Our golfer would probably need to find a way to anchor themselves on a lunar upslope to let a driver rip while also achieving a 45 launch angle. My God, so technical. But if a pro were able to do so and achieve the tour average ball speed of 278.18 kilometres an hour, the ball would travel at about 3.69 kilometres. The tour's longest hitter, Roy McIlroy, with his average ball speed of 296.88 kilometres an hour, could hit a lunar golf ball even farther, out to about 4.19 kilometres. So let's take the golfer to the moon and take his spacesuit off and see what happens then. Actually, there is original video footage here I've got of my Alan Shepard trying to hit this golf ball, and I'll see if I can play that. It's very, very poor resolution video, but you can make out two astronauts and one attempting to hit a golf ball. It only goes for, I think, maybe 60 seconds or so. I think there's some audio attached to this as well, so I hope I better put my headphones on so I know that I'm not overdriving in any way. Just bear with me while I get my headphones ready and put that on there. And there I am. 1, 2, 3, 4. All right, let's see if we can just get this. And so for those not seeing any video, this is going to be on RTV and also on my YouTube stream. So So let's see what happens here. This is VK3CSJ. Sorry, VK3EKH. Oh dear. Audio.
Yes, the line you're looking at, you might recognize what I have in my hand as the handle for the contingency sample return. It just still happens to have a Indian. Yes, the line you're looking at, you might recognize what I have in my hand as the handle for the contingency sample return. It just still happens to have a Indian 6 iron on the bottom of it. In my left hand I have a little white pellet that somebody in the millions of Americans drop it down. Unfortunately, the scissors so stiff I can't do it with 2 hands, but I'm going to try a little sand trap shot here. They got more dirt than ball this time. Some more dirt than ball. Here we go again. That looked like a slice to me, Al. There we go. 3 of the time. One more. Miles and miles and miles.
Well, that might not have sounded too great. Over 80 meters. It certainly didn't really sound too much in the headphones either. But nevertheless, that was real footage of Alan Shepard on the moon using a golf club or something akin to a golf club, hitting a ball which he figured went for miles and miles and miles. But in the analysed photograph, which I was showing before, which was this one here, the astronaut was standing, I think, somewhere in the shadow, in that shadow of the dish there, and of course you can see where ball 1 and ball 2 went. So it wasn't all that far. That was partly because the astronaut was in a spacesuit and wasn't able to tee off properly enough. Anyway, all right, enough of that. I'm not really interested in golf, so there it was. Oh dear. Okay, you're tuned to ASV Radio VK3EKH. Thanks for astronomy.com for that as well. Next article is something to do with Beagle. It's 18, coming up to 18 minutes to the hour. And okay, let me see. There's a little artist's impression here of Beagle, the lander on Mars. And okay, how the Beagle 2 was lost, then found on Mars. Okay, just making sure my audio levels are all okay here. After that, a bit of mucking around. The craft that, hang on a sec, 1, 2, 1, 2, just making sure not overdriving YouTube. Okay, Struth. The craft should have spent up to 6 months on Mars searching for chemical signatures of ancient life. April 21. When the hell did I get April from? This article was published December 21, not April. Oh, God. Just south of Mars' equator, abutting the red planet's crater-studded highlands and smooth-rolling lowlands, lies a broad plain wider than Texas. Likely carved by a colossal impact more than 3.9 billion years ago, the blasted terrain of Isidius Plantitia, a vast landscape of pitted ridges, light-coloured ripples and low dunes, today provides a further home and tomb for one of Mars's unluckiest robotic visitors. This would-be Martian invader made landfall 20 Christmases ago, never to be heard from again. Dead virtually on arrival on the planet and today dust-streaked and partly buried in abrasive sand, Britain's ill-fated Beagle 2 is now faintly visible to only only our most advanced optics as a bright smudge amid an endless sea of wind-whipped dust. It furnishes a stark reminder of the challenges of landing on this unforgiving world next door. The fate of Beagle 2, which initiated its descent to the surface early in Christmas Day, on Christmas Day 2003, seemingly in good health, before vanishing like a blip from a radar screen, provided a thornily, intractable mystery for more than a decade. Its intended touchdown spot near the eastern edge of a 930-mile or 1,500 kilometre Isidis Planitia would be repeatedly scoured by numerous orbiting spacecraft for clues. But Beagle's 2 smallness, just 6.5 feet or 1.9 metres across when fully deployed, but its detection just beyond the limits of available optics. Truly an earthly needle in a Martian haystack. Many believed the 73-pound or 33.2 kilometre lander would never again be seen by human eyes. Another woeful addition to a growing corpus of failed attempts to reach the world that might long ago have harboured life, bodies of water, life-bearing minerals, and perhaps even the murmurings of primeval life itself. And I think there's another image here of this article. Is there? Maybe not. Okay, all right, I'll just do this then. Okay, I thought there was another picture. Oh yeah, there's a video, a short video. All right, I'll get that running in a minute. Right, so its loss was a pity for Beagle 2, named for HMS Beagle, the Royal Navy brig sloop that in 1831-1836 carried British naturalist Charles Darwin on a round-the-world voyage to seek evidence of his origin of species. Should have spent up to 6 months on Mars, scooping soil and analysing the chemical signatures of ancient life. Its 109-centimetre robotic arm housed stereoscopic cameras, a microscope and a pair of spectrometers, a versatile sample drill and a burrowing mole. Beagle 2 hitched its 400 million kilometre ride to the Red Planet aboard Mars Express, a boxy 1-ton spacecraft bristling with 8 scientific instruments to map Mars at resolutions finer than 10 metres. Spectroscopically survey mineral concentrations and scrutinise the thin carbon dioxide-rich atmosphere and its interactions with the interplanetary medium. 2 radar antennas, each 20 metres long, facilitated the sounding of Mars' surface to a depth of 2 kilometres. This powerful toolkit underpinned a fundamental scientific goal of Mars Express that could be summed in one word: water. Whether it existed in the Red Planet's more benign, habitable past, where it went and if it harboured life. Mars Express was Europe's first independent foray to the Red Planet, after the Russian-European Mars 96 Proton K rocket failed during ascent in November 1996. The European Space Agency decided to stage its own mission. A tempting launch window in May-June 2003 fell when Earth and Mars were closest in their respective orbits, only 56 million kilometres apart. But engineers were challenged by a tight time frame to develop, build, test and launch it. Cost and time were saved by reusing existing or off-the-shelf hardware, handing full responsibility to prime contractor Matra Marconi Space and implementing new program management strategies. 150 million euros or 175 million USD in 1999 or 316 million today was the cheapest ever Mars mission, and the name Express carried dual meanings. underscoring both a rapid concept-to-launch architecture and an exceptionally short cruise time to Mars, lasting just 6 months. Delayed by a faulty electronics module, Mars Express took flight atop a Soyuz rocket from Russia's Cosmodrome in Kazakhstan at 11:45 p.m. local time, June 2, 2003. After a half-year cruise through inner solar system, Beagle 2 was jettisoned on December 19, and after 5 days of ballistic flight, plunged into Mars' atmosphere. Guarded from extreme deceleration temperatures by a hardy heat shield, a pair of parachutes and 3 airbags would carry the lander to a soft touchdown early Christmas morning. But Europe's visit from Santa never came. Efforts to call the lander by NASA's Mars Odyssey and ground-based observatories, including UK's Jodrell Bank, provided fruitless. And when Mars Express overflew the intended landing site early in January 2004, its attempt to facilitate contact via ultra-high frequency communication also came to nothing. Beagle 2, it seemed, had vanished without a trace. A month later, it was officially declared lost, and in May 2004, a UK ESA inquiry found no single technical cause or fault, but pinpointed a pragmatic and organisational issues that increased a risk of failure. Still, the search for the hapless lander continued, its inexplicable disappearance a mystery. Imagery from NASA's Mars Global Surveyor in 2005 revealed an unfamiliar black spot, briefly elevating hopes that it could be Beagle 2. But optical analysis concluded it was an eroded crater. Finally, January 2015 observations of the high-resolution imaging science experiment, or HiRISE, on NASA's 2006 launched Mars Reconnaissance Orbiter found a curious feature quite unlike any of the rocks or soil around it. Multiple images revealed several objects and locations where Beagle 2 heat shield and parachute ought to have landed. Their shapes, structures, and shadows they cast provides consistent with a bowl-shaped lander. It was a remarkable achievement. With Beagle 2 found, it became apparent that the lander had reached the ground in one piece, tantalizingly close to its targeted spot, but it seemed that at most only 2 or 3 of its 4 petal-like solar arrays had unfurled, blocking its radio antenna and preventing it from communicating its status or transmitting any data. This triumph of successful landing was tempered by a disappointment for a mission which came to close success. There was also profound sadness for Beagle 2 principal investigator Colin Pillinger of the UK's Open University had died only a few months earlier in May 2014. He went to his grave never knowing the fault of his labours had, against so many odds, made it safely to Mars' surface after all. Pillinger did, however, live to see some of his achievements of Mars Express, which is today the second longest lived orbiter of the Red Planet. Its 2 decades of continuous service surpassed only by NASA's 2001 launched Mars Odyssey. From its elongated polar orbit, it has confirmed the presence of methane in the planet's atmosphere, discovered the global extent of Martian aurorae, and pinpointed high-altitude clouds residing 80 to 100 kilometres above the surface. It offered tantalising hints that ancient water once flowed here, from traces of flooding at the Mangala Vallis to a frozen sea in the equatorial Elysium Planitia, from water ice patches at the extreme northerly latitudes of the Vestissa Borealis to sulfate deposits in the Genevity Chasm, and from possible river channels in the Nepenthes Mensa and Rural Vallis to hydrate silicates in Mars's northern highlands. In 2019, it provided evidence of an unconnected underground network of lakes, 5 of which contained minerals necessary for life. Mars Express data revealed that solar wind erosion may have contributed to the gradual disappearance of the thin atmosphere, and in 2007 it watched a fearsome dust storm ravage the planet, temporarily raising global temperatures by 20 to 30 degrees Celsius. It uncovered curious windblown sand features called yardangs, or escarpments, and landslides, and it helped to date major Martian volcanic tectonic events into 5 discrete epochs spanning timescales from 3.8 billion to 100 million years ago. The orbiter also completed multiple close flybys of Phobos, revealing Mars's largest moon to be battered rubble pile of aggregate debris with a porosity of 25 to 35%. As if to make amends, the loss of the Beagle 2, the hardy little spacecraft, also supported other landings, helping to guide NASA's Phoenix lander and Curiosity rover to smooth on-point touchdowns in 2008 and 2012. Its visual monitoring camera, originally an engineering tool to monitor Beagle 2, was repurposed in 2008 as a Mars webcam for public outreach, and with its mission of exploration having surpassed 20,000 orbits of Mars and operations extended until the end of 2026, it surely has much more to contribute. Right, and this short video, which kind of shows all right, let me just see where it is here. I know I've got it here. I always seem to forget to bring something across that I save. That's it there, isn't it? Okay. Oh no, it is there. Oh, my goodness me. All right, bring this up. There we are. And there's a bit of sound associated with this too, I think.
The movie you're watching here is a sequence of 3 high-rise images that were taken of an object that might be the Beagle 2 lander in Isidis Planitia. It was seen first as a series of bright spots. These bright spots are not uncommon in spacecraft images as cosmic rays strike the CCD. It's in 2 of the high-rise images, so we know they're on the ground. They're not artifacts of a cosmic ray strike on the CCD. The 3rd image was taken recently, and I've taken the color channel from that 3rd image and I've used it to colorize the first 2. The object itself seems to have different points on it that are catching glints from one image to another. From this, we're interpreting that we may actually be looking at the Beagle 2 lander and that it is actually in some deployed condition. Whether all the panels have been opened up or not is yet to be determined by the Beagle team.
Okay, so thank you NASA for that, and astronomy.com courtesy. So yes, there it is. Beagle 2's been found. And it appears that it did land okay, more or less. It's just it's one of its solar panels when it deployed for some reason went across the main antenna to pass signals back to Earth and shielded it. These things, I tell you. You're tuned to ASV Radio, VK3EKH. Not too far from 11 o'clock. I might just quickly read this one out because this was published 2 days ago. Thanks to space.com. And there is a graphic for this too. Where are we with that graphic? There it is. Okay, so the article is Strange Slide Whistle, Fast Radio Burst Picked Up by Alien Hunting Telescope Defies Explanation. The fascinating patterns of 35 repeating fast radio bursts reveal new properties of these mysterious blasts of deep space radiation that appear and disappear in milliseconds. And what you're seeing there is an illustration shows mysterious fast radio bursts are bombarded Earth from deep space. There it is. Astronomers watched 35 explosive outbursts from a rare repeating fast radio burst as it shifted in frequency like a cosmic slide whistle, blinking in a puzzling pattern never seen before. Fast radio bursts are millisecond-long flashes of light from beyond the Milky Way that are capable of producing as much energy in a few seconds as the Sun does in a year. FRBs are believed to come from powerful objects like neutron stars with intense magnetic fields, also called magnetars, or from catalytic events like stellar collisions or the collapse of neutron stars to form black holes. Complicating FRB picture, a few FRBs are repeaters that flash from the same spot in the sky more than once, while the majority burst once and then vanish. The team behind the new research used the SETI Institute Allen Telescope Array, ATA, to study the highly active repeating FRB known as FRB 2022-0912A. As they watched the FRB over 541 hours, nearly 23 days, the team saw its bursts of radiation cover a wide range of frequencies in the radio wave region of the electromagnetic spectrum, which eventually developed into a fascinating pattern that astronomers had never seen before. The new data could finally help unravel the mystery of where deep space FRBs come from and why a small minority of these rapid and intense blasts of radiation repeat. This work is exciting because it provides both confirmation of known FRB properties and the discovery of some new ones, lead study author Sophia Seth, a postdoctoral fellow at the SETI Institute, said in a statement. We're narrowing down the source of FRBs, for example, to extreme objects such as magnetars, but no existing model can explain all the properties that have been observed so far. The findings were accepted for publication in the journal Monthly Notices of the Royal Astronomical Society, and there is a copy available. And the final comment here is that the author and colleagues found that the bursts of radiation from FRB 2022-0912A shifted down in frequency and then converted it to notes played on a xylophone. This shift sounded like a slide whistle descending toot, a behaviour that scientists had never seen before from an FRB. This also helped the team identify that there is a cut-off point for the brightness of bursts from FRB 2022-0912A, revealing how much of the overall cosmic signal rate this FRB is responsible for. And while there was a noticeable pattern in the frequency of FRB 2022-0912A's bursts, there was no clear pattern to how long these bursts lasted or how much time passed between them, and this shows there is an inherent unpredictability in repeating FRBs. In addition, the study demonstrated how SETI's ATA telescope, designed to hunt for radio signals from potential alien intelligence, has an important contribution to make to the study of FRBs and therefore some of the universe's most extreme events and objects. It has been wonderful to be a part of the first FRB study done with the ATA, and this work provides or proves that new telescopes with unique capabilities like the ATA can provide a new angle on outstanding mysteries in FRB science, the author said. So, yes, FRBs, the research continues. You're tuned to ASV Radio, VK3EKH, where it's gone, 11:02. And I'm just going to show you a quick picture here from the James Webb Space Telescope. Now, there is an article, but I won't read it out now. Suffice to say that you can find it on space.com. But the rings of Uranus look positively festive in epic James Webb Space Telescope holiday photo. This is taken or published 4 days ago. This new portrait of the seventh planet from the Sun reveals more of the atmosphere's workings as it nears its solstice in 2028. They say here that this may not be the gold rings from the 12 days of Christmas, but Uranus and its rings stand resplendent in the stunning portrait from the James Webb Space Telescope. It's the second image of Uranus that the JWST has captured this year, and the first, released in April, was a two-toned affair composed of imagery captured in infrared wavelengths. The new James Webb Space Telescope's Uranus image doesn't show the planet. However, Uranus and aforementioned rings shine bright in an infrared light, and James Webb Space Telescope's optics have been resolved with the elusive diffuse inner Zeta ring. Many of Uranus's 27 moons are also on display. The cropped view shows some of Uranus's smaller, fainter moons, including some embedded within the rings, while the wider view shows Uranus' 5 larger moons. So, yeah, there's a bit more to that, but I'll leave it there. But there it is, an infrared image of Uranus showing its multiple rings there and some of its moons. So, yes, if Uranus was just a closer world, we'd be able to see it by eye. Anyway, it's one of those objects I hope to be able to picture or photograph through the telescope when my observatory gets up and running. Solar weather. Solar weather. The disk of the Sun is currently looking like this for those watching the video side of the transmission. We have a Sun that's got 1, 2, 3, 4, 5, 6, 7, 8 sunspots on the disk of the Sun currently facing us. The solar wind is currently at 336.8 kilometers a second at a density of 1.66 protons per cubic centimeter. The current sunspot number is 138, whilst the radio sun, measured at a wavelength of 10.7 centimeters, is 194 solar flux units. The KP index, planetary K index, currently is 1.67, which is considered quiet. The 24-hour max KP figure is 1.67, also considered quiet. There are no significant coronal holes on the Earth side of the Sun at this point in time. Chances of flares today. Don't be surprised if there is an M-class solar flare today. At least 3 sunspots have unstable magnetic fields teetering on the edge of such an explosion. And there is a little graphic here, a GIF image I've got. Did I bring that across or didn't I? It's another one I didn't bring across. Video, browse, there it is. That just didn't bring it across. And here it is. And just put it in a loop. Alright, so what you're seeing on the screen there, so these are sunspot regions AR3519, AR3521 and AR3529. NOAA forecasters peg the odds of 40%. Any flares will probably what's that word? Anyway, 2 of sunspots are directly facing Earth. But what you're seeing on the screen is an M3 class solar flare from AR3519, which is on the far eastern side of the limb of the Sun at this stage, giving us a flash, pretty decent flash. Okay, so there's not much else to report on. Even the aurora over the South Pole is very vague. Not much to write home about. So there's no aurorae to see at this stage, or aurora australis. It's all very low key. But that could change in the next 24 hours. And the final thing is for the year, potentially hazardous asteroids, which are space rocks larger than approximately 100 meters, and that can come close to Earth than 0.05 AU. None of the known PHAs is on a collision course with our planet. although astronomers are finding new ones all the time. As of December 22nd, 2023, there are 2,349 potential hazardous asteroids. So there it is. That's pretty much space weather there. Spaceweather.com. And that's it. I got through all those articles in a very brief sort of a way. So anyway, on that note, I want to thank everybody this year for hanging in to the dulcet tones of myself and being regulars, and the fellows the stations that come and go once in a while. I thank you, that Blakes too, for popping in, as they say. And it's been another long 12 months, although it seems to have gone very quick to me. But we'll be back on the 19th of January to do it all again, and hopefully from a new studio environment. And hopefully we'll get things more sorted out downstairs once I get a chance to reconfigure things, I suppose. On that note, we shall just have a quick listen on the frequency if there's any stations wishing to call in. This is VK3 EKH listing 3541. Okay, VK3GL, VK3VIN, VK3SPX, and VK7JAH. Anybody else? Ooh, badly distorted audio. Try again. Yeah, that last station was really... audio was way off. You might want to turn your gain down or something or other. I'll just listen for you one more time there. Well, that was better. We got you that time. Right, VK3AOB, no worries. Thanks, Brett. All right, Graham, VK3GL, VK3EKH. G'day, mate. Yeah, thanks, Graham. VK3GL, VK3EKH returning. I've just taken off my headphones. Oh, God, it's different. All right, thanks, Graham. You're about 20 over 9 here tonight, so good signal yourself, and thanks for the kind comments. And yes, I saw the golfing one, and I thought, oh, well, that'll be an interesting one to work my way through. So, yeah, but I can remember the astronauts doing that, Apollo 14. and also like the other video that they've got. I can't remember which Apollo mission it was, but they were dropping a hammer and a feather, and in a no atmosphere environment, the hammer and the feather dropped at the same rate, proving a point. So I remember that. Anyway, that's another story. Thanks, Graham. We'll probably catch up. As you know, I've got 4 weeks off, so we'll probably catch up over the Christmas break at some point in time. Thanks, Graham. Across to you there, Ian, VK3VIN, VK3EKH. Thanks, Ian. VK3VIN, VK3EKH. Yeah, very good. Note the signal report, and you're hovering pretty much on 10 over 9 here at the moment, 10 to 15 over 9, so a fairly consistent signal here, not a problem at all. And yes, look, there's it's a lot of that Apollo footage available to view now on YouTube. If you know the places to go to, it's all very easy to, well, I won't say it's easy to find, but it is there, and particularly the stuff that's been remastered. It was certainly a time to be had, that is for sure. Anyway, thanks, Ian. Merry Christmas to you too, and all the best, and all the best for 2024. Thanks, Ian. Steve, VK3SBX, VK3EKH.
Broadcast for the year. That's a terrific job to do there, and we'll be looking forward to the new year. There was a few interesting things today. I was quite interested in the description of the upcoming, 4 billion years away anyway, collision between Andromeda and the Milky Way, and possible black hole collision there. Interesting stuff. I mean, I don't suppose anybody's going to be around to see it, but it would be interesting that the night sky would look just so much different than it does today. Very interesting. And I was also intrigued by the Gulf on the Moon, quite a technical description of the effect of air on projectile motion and what have you. Interesting that, on Earth, the optimum angle is so much lower than the sort of, technically optimal 45 degrees because of the way the Gulf ball spins. And, pretty impressive how far it would go on the Moon if you really were able to do it properly. Pretty good. I wasn't sure I was going to make it today, actually. There was a pretty widespread blackout here in central Victoria, I think due to a bushfire somewhere, somewhat north of Malden, and there was, quite a lot of towns around this area blacked out a few hours ago, and it even went out about a quarter of an hour before the broadcast for a minute or two, so I thought, oh, look, here we go again, but it came back on. So, anyway, it all worked out, and makes me think I might get a battery, but I'll do that one day. All right, thanks very much, Clint, and we'll see you again next year, VK3, EKH, VK3SBX.
Thanks, Steve. VK3SBX, VK3EKH. Yeah, a sign of of things to come, isn't it? There's it's going to be some very, very funny weather patterns coming up, I think, and for this summer period. So let's just hope that fire isn't going to be an issue for Victoria or anywhere else for that matter. But I mean, look at the floods up in Queensland. So, God, this country, I tell you. But nevertheless, yeah, thanks, Steve. Good to hear. And I'm hoping for my dome to be installed fairly soon. I've got the chap coming around tomorrow to re-level the deck. I think you're aware that the deck's not level. That was the problem. It slants by about 20 millimetre at one end, so the dome doesn't rotate properly. The deck needs to be absolute flat. So I've got the builder coming back tomorrow to work on that and try and flatten the deck out. And hopefully he'll do it all in the one day. Because if it's successful, then I'll notify the install team. It'll be probably sometime after Christmas, but hopefully it'll all be done by the time I go back to work. So I'll get a chance to set up a telescope and see how we go. But I'll let you know. I'll send you an email on that one if anything transpires. Thanks, Steve. And now we go across to Martin down in Launceston, VK7, JAH, VK3EKH.
In the near future. But no, good signal down here. Not quite as brilliant. The voice score is actually quite high down here at the moment. It's probably a bit weather related, to be quite honest. It's good down here, but it's thanks to you. A little bit unpleasant around the rest of Australia. So, especially with the rainfall and stuff like that. Nevertheless, we're extremely well. And YouTube held up extremely well as well. Had a couple of things, the bounds goes themselves. Not sure if that was my end or your end, but it doesn't really matter. At the end of the day, we got exactly 3 and here, all of your broadcasts extremely well. So all I'll say now is happy Christmas, happy New Year, and look forward to talking to you again on the next episode.
Thanks, Martin. VK7, JAH, VK3EKH, returning. Very good. And the same to you, dear sir. All the best for Christmas time season, and all the best for 2024 too. And yes, I can see that the stream has held up. I think that's partly because I've had to change the modem. The modem that it's a black box type modem. It's a Telstra thing, but it's capable of Wi-Fi 6, and it's been playing up. This is the third modem that's been replaced of the same model, and but it appears it's very prone to RF. Now I've gone back. It failed. The last one failed, and I haven't bothered telling Telstra. I said, "Well, screw you, I don't need a replacement if it's going to keep failing." So I've gone back to an older modem, which is working fine, really, and so far the stream's been hanging in. So this older modem, I think, is working just a little bit better from an RF immunity aspect. But nevertheless, that's another story. Thanks, Martin. You're about, well, I've got you down as 15 to 20 over 9 peaking. It did peak to 20 over 9, it seems. So, but you're hovering around 5 and 9, basically. And, yeah, so there it is. Okay. I think that was about it there. But look, thanks for the comments, and thanks for hanging in all this time and being a regular too. So it's quite good. Good to see the signal gets down to the southern part. Now it's across to Brit, VK3 AOB, VK3 EKH.
Yeah, fine, Clint, no problem. How's that signal sound okay?
Yeah, good 20 over 9 at the moment.
Roger, yeah, you're 5 by 9 plus 20, and occasionally getting as high as plus 30, so it's quite a good signal. Yeah, good little broadcast tonight. Sounds quite good, and interesting stories. Yeah, the poor old beagle. Yeah, the solar things don't open up. The dish can't see things, and you can't get a signal. Maybe it's got into a hole in the ground a bit, so it can't open them up. Anyway, whatever happened is what happened. Yeah, so there you go. I recently bought a telescope. It's a second hand from the cash converters. I saw it there, $160 odd. I haven't even tried it yet. It's in the front bedroom, my front storeroom. So I'm just waiting for us to get a proper summer. We're getting a warm night. It's a bit cold out there. I came home, what time was it? Around about 10 o'clock, and the moon was up. There's a bit of cloud in front of it. And it didn't seem to be too conducive to observing stars, so I didn't bother. Just threw the car in the garage, locked it up, locked the garage, came in, and that's it. Yeah, so there you go. Well, enjoy your 4 weeks off, and we'll wait and see what you come up with in mid-January, so that'll be good. Yeah, I like the old astronomy, and fascinating subject. VK3 EKH, VK3 AOB. Enjoy your Christmas break.
Yep, thanks, Brett. VK3 AOB, VK3 EKH returning, VK3 CSJ on the microphone. No worries, Brett. Yeah, astronomy is well. If you've got an interest in the stars, and I mean, this is the time to be interested in astronomy, because what we're learning about the universe day by day is just amazing. The images that are coming through from all these instruments that we have, either in space or Earth ground observatories, is just it's just amazing what we're learning, and the scientists or astronomers that are devoting their almost their whole life to research into these areas is quite amazing. So there's some of the websites, like the ones that I go to frequently, astronomy.com and others, are always keeping you abreast of what's new and what's happening. So like I say, every week there's always some interesting news article that of something happening. So yeah, and as far as optical astronomy is concerned for the amateur, well, like I say, I'm pretty close to getting my own observatory up and running, and I've got 3 telescopes to explore over time. And of course, the main crux of what I want to try and do, pardon the pun, is to take photographs, take images of some deep sky objects, and then just stick them up on the internet. But as I explore that and discover how that's all done and what has to be done to be able to do this, I can easily mention it here and talk about it. and you know, pave the way for young astronomers or other astronomers wanting to do the same thing. Because honestly, once upon a time, doing astrophotography was a slightly different approach, particularly before CCD cameras came online. Putting a film camera onto the end of a telescope was the way to do it, and then develop it. But that's going back a fair ways. But certainly the kind of cameras that are now available to attach to a camera, and the filter, the various filters that you can apply to the image that you're looking at to just enhance the image even further. It's just amazing stuff. And then the end result is clearly also just amazing. It's almost rivals what the Hubble does. Not quite, but close with some people's systems. But it's a lot of money. It can be a lot of money, astronomy, to set up your own observatory. Telescopes aren't cheap, and the associated hardware isn't cheap. It's unfortunate that it's pretty expensive, but you know, if you know what you're doing, you're paying for the right equipment, and you'll get results. And then it comes the software, the computer programs that are used to enhance these images yet again. So it's pretty amazing what can be done. Yes, and of course there's also radio astronomy. Just the basics of radio astronomy, trying to detect solar flares and trying to detect decametric emissions from Jupiter, and trying to detect the center of our galaxy. You know, all that's easy to do with a dipole and a good receiver and an RF quiet location. It's important too. Anyway, enough of that waffle. Is there any other stations wishing to check in? VK3 EKH. On that note, thanks everybody again for tuning in and listening in. It's been good to be able to come up here on Friday nights to impart the latest in news on astronomy. And for a broadcast, it's been running since 1988. And if Russell, if you're listening, dear sir, a Merry Christmas to you, VK3DRW. Russell was the first person on the microphone here for 20 years. He maintained the regular Friday night broadcast before I decided to take over. So cheers to you, Russell, if you're there. Meanwhile, take care, everyone. Look after yourselves. I might just suggest that keep an eye on Brendan O'Brien's Astrophiz website. He's up to episode 184, is it? 81 to, might be 80, episode of his podcast, 184. Astrophiz.com, Astrophiz, P-H-I-Z, Astrophiz.com. He has some very, very interesting podcasts there. Bit of a plug for Brendan. And we also say a very pleasant good evening to their Steve, Dave, VK3 KDM from the MBO. G'day Joe, VK3BKI. And yes, so they're on the chat window there. Thanks for calling in on the chat window. Cheers to you there, Wayne, and Andrew that have called in on the email side of it. And good signal up there by the sounds of it there. Excellent. Merry Christmas to you all, and all the best for 2024. Enjoy New Year's Eve and just go wild, okay? But don't hurt yourselves. Anyway, all right, this is VK3 Echo Kilo Hotel. This is the last time for 2023, and we'll be back on the 19th of January from different studios, hopefully. This is VK3 EKH with VK3 CSJ on the microphone, concluding transmissions 3541 kilohertz, and we say evening. Cheers, everyone. All right, so to my YouTubers, that sounds like Kelvin. All right, I'll hang. Look. turn that down. Yeah, so to my YouTubers and to the ATVers up there, thank you for watching on the HD side of things, this side of town. We'll be continuing to do the WIA broadcast on Sunday morning at 10:30 and also on 160 metres AM at 9 o'clock. Yes, doing the WIA broadcast and repeating again at 8 o'clock on Sunday evening. But otherwise, the Friday night time slot is free for anybody else to use for the next 4 weeks. If anybody is inclined to use it. On RTV1. So on that note, we shall conclude and rest my eyes from all these bright lights. So this is VK3 EKH with VK3 CSJ on the microphone, concluding for this year, 2023, the ASV radio broadcast. I wish Merry Christmas to everybody and a Happy New Year. So all take care and be back in 2024 healthy, wealthy and wise. All right, cheers everyone, bye.